Our next creation pattern is the factory method pattern. We have essentially the same problem statement that we had for an abstract factory pattern. And in fact, the factory method pattern and the abstract factory pattern can be used in conjunction with each other, and we'll see that in the example. Our basic problem is that our app needs to support multiple database types. Maybe SQL Server, or Oracle, or MySQL, or maybe we're just setting the app up so that it can expand to a different database type in the future. For instance, we might be using MySQL now, but we expect great things and we're going to scale to a huge Oracle data farm later on. We don't want our app to know anything about the database type throughout the application code, so we don't want to have a bunch of switches that say, if it's a SQL Server command, do this. If it's a Oracle command, do that. We don't want all of that if-then kind of stuff in the app itself. We want to isolate that. In measurement, data can come from a lot of different sources. It might be a serial port source, or an Ethernet source, or a device driver, perhaps Modbus or OPC. There are a number of different places that data can come in. Measurement apps often have different data sources that combine. So you may have pressure sensors in one place and temperature sensors in another, and they're all coming in on different buses and different ports. We need to be able to manage that. But again, we don't want the data to be tangled up with the actual source type. And we don't want the code to deal with the source type to be spread throughout the application. And another possibility is we might need to create a different report type. The user may want to select a PDF type or a Word or maybe an Excel doc, and we'll need to be able to support those different report types. But again, we don't want the application and the report generator to really know anything about that. We want that area to understand about creating the data that they need. The actual formatting into a document should be done elsewhere. So what a factory method does is it provides a method to create class instances. If you remember in the abstract factory, we had different classes that inherited from an abstract class that presented a more generic interface that the application used. That was great, but what we didn't have was the creation part. In our application code, we had this if-then section. If it's SQL Server, create the SQL Server database class. Else, if it's Oracle, create the Oracle database class. And you can imagine, if we're going to do that throughout the application, that that's going to be messy. So we don't really want that. So the factory method provides us a nice way of creating those classes and isolating that from the application code. So we use this a lot with the abstract factory, and it provides us a nice single method for creating those applications. And again, it hides the details of creating objects from the rest of the application. And we did a similar kind of thing with the builder pattern. And in fact, when we get through this, you may see how you could use the abstract factory, the builder, and the factory method all in conjunction with each other to create a lot of different types of classes that have complicated construction methods. So the factory class will create an instance of a class that inherits or implements the abstract class. So as a basic example, we have an abstract factory that has our database abstract class, and it again has a connection property and a command property. And this is the same thing that we talked about in the abstract factory. Then we'll have SQL Server and OLEDB derived classes. We could have Oracle classes or MySQL classes as well. Just more different types of database classes, and they're specific and they actually have implementation, where the abstract class does not have any particular implementation. And then we have an enum for the database type. And this is where we're starting to get into the factory method pattern. The enum will tell the factory method what type of database we want to create, whether it be SQL Server or OLEDB or whatever. And then we'll have a database factory class for the actual database class creation. And this is going to be a single static method. We also have some implementation choices. The abstract factory pattern, of course, uses an abstract class. But we could also instead use an interface rather than the abstract class. So we can use the interface for the command property and the connection property instead of the abstract class. In the abstract factory example, you could see how the abstract class didn't actually have any implementation, so it could have easily been done with an interface. Now your mileage may vary on that. You may have some code that's common to all the different types of factory classes that you're creating that you do indeed want to be in that base class. But if you don't, an interface might be a better choice because it enforces that contract on all of the classes that implement it. And that's one of the important distinctions. The interface does require implementation in the concrete classes. So any class that's going to implement this interface is required to implement all of the methods, properties, and events on the interface. So your application code knows that it's going to have a consistent, fully implemented interface. And of course, the interface doesn't have any implementation within its code itself. So there's no base interface code or implementation. If you want or need that, in that case, you actually should use the abstract class. So a factory can return an interface rather than a class. And the use of abstract class might be appropriate as well. So again, this is one of those choices that you can make. In our class diagram, we have our database factory, and the database factory will be the factory method, and it will have a static method called createDatabase. And the parameter in createDatabase will be an enum, and that'll be that database type. And in this case, we just have SQL Server OLADB. And then you can see our interface for iDatabase, which has the command and connection properties. And then the implementation classes for SQL Server Database have a command and a connection. And the command and connection properties on the interface are going to be the abstract type, DB connection, and DB command. Whereas the SQL Server Database, they will probably be of type SQL command and SQL connection, but those, of course, inherit from DB connection and DB command. And then OLADB is the same thing. There'll be an OLADB command and an OLADB connection, and they inherit from DB command and DB connection. So both SQL Server Database and OLADB Database implement the iDatabase interface, and the database factory method, createDatabase, is going to return a type iDatabase. It won't be returning a SQL Server database or an OLADB database. Its return signature will be iDatabase, so it could return either the SQL Server or the OLADB. So in that way, the only thing the application code needs to know is iDatabase. And the only thing the application has to know to build the iDatabase object is the database factory method, createDatabase. So there's not a whole lot of extra construction information that it needs to know. In fact, that factory method doesn't necessarily have to have a parameter of that database enum type. So the application doesn't even necessarily have to know that. It could come from a configuration file, for instance. On this installation, we're using SQL Server. Therefore, the enum is SQL Server, and the database factory reads that out of the configuration information, and the application essentially doesn't know anything about the type whatsoever. It just calls the database factory and says, create me a database, and it gets an object that implements iDatabase, and it goes from there, and is able to use it throughout the application code. So this really can isolate the application from all of those construction details. And if these classes that implement iDatabase were really complicated to build and had multi-step construction processes, then we could use a builder pattern within the database factory method pattern in order to create the database object and keep all of that nasty code isolated from the application. So in that case, we'd actually be using the abstract factory pattern, the builder pattern, and the factory method pattern all in conjunction with each other to create multi-type complex objects and keep all of that code completely isolated from the application. All of these three patterns are in a group called creation patterns. So they're all about creating objects and keeping all of that complicated creation logic away from the rest of the application code. The application code just wants to use the objects. It doesn't want to know the gory details about creating them. So that's the factory method pattern. And we'll be moving on to a code example in the next lesson.